Hi guys, this is video number 10 for the chapter of linear programming. Continuing with the examples we are doing for converting the word problem into a linear inequation, or rather we'll use the term LPP now. We have done the manufacturing problem, which was a sum of profit. We also did a sum which was based on the diet, so that was a sum where we were required to minimize the cost. Now let's take an example, okay, which is quite common, and it is an investment related problem. Right, so here we have the question as there is a person who is wishing to purchase, okay, some fans and some sewing machines. What are the conditions under which he is going to do his business? Is that he has rupees 5,760 to invest, and at the same time he has space only for 20 items. So this sounds like quite a realistic problem. There is a shop owner, he has some particular investment amount to do, and then he has space for those many items only. Alright, and what is happening is that a sewing machine or rather a fan is costing him 360 rupees, whereas the sewing machine is costing him 240 rupees. When he is selling it off, he is thinking of making a profit of 22 on the fan and rupees 18 on the sewing machine. You have to formulate this as an LPP to maximize his profit. Alright, the purpose of the sum is to maximize the profit. So we have identified step 1 is done. Step number 2 is to determine what are the decision variables. तो what is the x and y going to be? यार तुम एक शॉप लेके बैठे हो, आपको स्विंग मशीन और आपके फैंस सेल करने हैं, राइट? एंड यू वांट टू नो कि अगर मेरे पास 20 आइटम्स की स्पेस है तो मैं कितने मशीन्स और कितने फैंस लेके आऊंगा. दैट इज गोइंग टू बी द क्वेश्चन, राइट? सो जस्ट दैट कन्वर्टेड इनटू मैथ्स, यू विल राइट इट एज लेट x fans and y sewing machines be purchased and at the same time sold. I will now try to, we have finished step 2 steps. I will now try to tabulate the information that is given, and then we will look forward to completing the remaining steps. So the given information can be tabulated as follows. So we are talking about fans and sewing machines. So we'll put it here, as we decided that x and y will be columns. So fans is going to be x and sewing machines is going to be your y. Well, the first thing that you realize is that he has a particular constraint on two things. That's the sum, that's the beginning of the sum. He has rupees 5,760 to invest, and the maximum space that he has is for 20 items. So accordingly, the conditions, the constraints under which he has to do his business will be written here. So one of them is investment, and the other is the space. The first line tells you he has 5,760 as the maximum investment, and he has space for just 20 items. So this is the max availability. Now, see, when you're talking about utilizing the space, you are actually going to keep in the space the fans and the sewing machines. So x fans and y sewing machines together has to be less than equal to 20. That's one of the condition, kind of a hidden condition that you are extracting from the question. Then we have the investment. So he sees that a fan is available for 360 rupees and the machine is available for 240. So one fan is costing him 360 rupees and one sewing machine is costing him 240 rupees. He has to buy x fans and y sewing machines, but he has to make sure that he spends less than 5,760. Talking about the profit, you know always profit is over here. 22 rupees on the fan, 18 rupees on the sewing machine, and he wants to maximize it. So ये जो profit वाला part है, यहाँ पर maximum profit is what you are looking for. You are supposed to write here x and y because that will give you the total profit, right? Let's convert it into the statement. Step 3 is to get the objective function. So we write here the total profit is z equal to 22x plus 18y, which is the objective function maximized. Let's pick up one constraint from the table. So we'll explain the investment part, and then similarly we'll write the space constraint. So X fans and Y sewing machines are costing him this much rupees. That's what we can write here. X fans and Y sewing machines cost rupees 360x plus 240y. However, the maximum investment is rupees 5760, and therefore you get 360x plus 240y less than equal to 5760, which you call constraints on investment. Having explained the first constraint, similarly the second one. Similarly, considering the limitations on space, x plus y should be less than equal to 20. This is the constraint on space. Let's finally write the non-negativity constraints. Since x and y represent the number of fans and sewing machines, or rather in short the number of items, that's what you can write. X and y cannot be negatives, where you write x comma y greater than equal to 0, justify it as the non-negativity constraints. Having finished all of it, time to write the LPP. The LPP is maximize z is equal to 22x plus 18y subject to, we have first the constraint of 360x plus 240y less than equal to 5760. We have x plus y less than equal to 20, and we have the non-negativity constraints where x and y have to be greater than equal to 0. So this is one investment related problem, and we have completed this sum by tabulating the information. Becomes easy as we see it. Let's take one more example where it will be a little difficult to tabulate the problem, or you can say that there can be some constraints which are not possible to tabulate and some of them will be within the table. So let's understand that kind of problem.